Hello guys, what up? So today, I'm sorry that I'm at the school right now. So that is why I cannot be very loud, but we still can get into it. So we'll start with the question numero uno. Question number one says, write this number as a product of prime numbers. So how do we do it? This is called a prime factorization, right? You already probably remember what is a prime factorization. Let me just work with my touchpad, which doesn't work very well. This is a very disgusting thing to do right now, but I kind of have to do it. Oh, the hell is going on? Okay, now it should work. So let's get started. So I did it wrong again. The hell? I can't learn this. Come on. This is 100 times I've done this, but again, I'm making a mistake on this. Says to be very stupid. Okay, sure. Now we gotta write the number as a product of prime numbers. This is the idea of doing that is called a prime factorization, right? Prime factorization. So then try to understand what is the idea behind the prime factorization. Let's think of a numbers, right? Any number, you can think of any number, okay? Of course, we're talking about the integers, right? Well, for the sake of this class, let's call it a natural numbers, not all integers, okay? Any natural number has two options, right? The number is either prime or non-prime. So we already know what a prime and what a non-prime is. I'm not going to repeat those. But essentially, non-prime. So now primes are just the numbers, right? For example, let's give an example. 17 means that it is a prime. Well, 17 is a prime, meaning that 17 is divisible by only itself and 1. Every guy is divisible by 1. So 17 is divisible by itself and 1. So there's only one way I can show 17, which is 17 times 1. The same things works for 13, for example, right? The same thing works for 15, for example, right? No, it's not right because for 15, I can only show it as 3 times 5. So 15 is not a prime. You see, it is not a prime. So 15 will be in this group, right? So if you are not a prime, then I can show you as a product of primes. Okay. If you are a prime, I can only show you as this. So 17 times 1, that's it. But if you are non-prime, then I can show you as product of primes. So what does it mean? We can now imagine the numbers, every number, as mm, product of primes as something that we are making, we are getting its result by using the primes. For example, you can think of a number 15 again. We can show the 15 as this. So these two guys, 3 and 5, gives me 15, right? Well, now think about, let's say, 115, for example. How am I gonna get this? I'm gonna get this as 5 and 23, I guess, right? 5 and 23. So these two guys gonna give me this guy. So the same ideology can be applied to 110, for example, right? 110. So it will be 5, 2, and 11 will give me 110. So these three guys are making 110. So, and now think about 17 itself. No one makes 17. 17 makes itself because 17 is a prime. Okay. So this is an essential idea. That's it. Now let's go back to the question. The question says, so any number then it means that any number, right? Any number can be written as a product of prime numbers. So this guy or this guy doesn't matter. Now think of the first guy over here. The first guy is 343. So we got to write it as a product of primes, which is called a prime factorization. What are the steps of doing prime factorization? Step one, step one, try first prime number, try first prime. What is the first prime? That is 2, right? Step 2. If not, so if it's not divisible by 2, if not, try next. Try next. We are only trying primes, so we gotta try next as 3, and the next is 5, next is 7, next is 11. You see, and the next is not 9 because we are only trying primes. 17, blah, blah, blah. So what is the last step? Last step is repeat. So every step, we're gonna repeat these steps. Now I'll show you how it goes. You'll understand what's going on. So 343, I think this was the number, right? Yes. So now we are doing the prime factorization. I know that you are doing it with the like factor 3 or something like that, but I'll go with my own method. They don't matter. Whatever you do doesn't matter. So we go with the step 1. Try first prime. 2. Is it divisible by 2? No. So we go to the second step because we are in the if not case, because it's not divisible by 2. So we see 2 for this doesn't work, right? Because it's not divisible by 2. So now we are trying the next prime, 3. Does it work? We try to divide, blah, blah, blah. There is a rule for like exactly knowing if it is divisible by 3 or not, but it's not a topic for this class. So 3 also doesn't work. Then we try 5, not 4, because we are only trying prime numbers. 5. 5 also doesn't work. Then we try 7. We see 7, we try and we see that 7 does work. Okay, you can do the calculation by yourself. We see that 7 does work. And the answer is when you divide it by 7, you will get 49. Now, since we already tried 2, 3, and 5, we don't need to try them with 49, okay? With 49, you can now start with 7 itself, okay? Because already 235 doesn't work with this whole number, 343, 234, 235 doesn't work, right? So they can't work with 49, okay? There is no way. So 49, we start with 7. If it's not divisible by 7, we will go with 11, okay? One by one. But luckily, it is divisible by 7. So 7 itself, we see that it's not divisible by anything else at this point. So 49, 7, we divide, answer is 7. So 7 itself, we see that it's a prime. It's only divisible by 7, and it gives me 1. Once you hit 1, sorry, it gives me 1. So step 4, stop once you hit 1. Okay, so we hit 1, we stop. So numbers we got is 7, 7, 7. And we got to show it as a product of primes. So we can write it as 343 is equal to 7, 7, 7. You can try it yourself and you will see that answer is correct. Now, the next one is 546. Good one. So again, we will try the prime numbers for 546. Let me see how many minutes has been this recording. That's nice. I can see it. Very good. Okay. So 546, we again start with the smallest prime, which is 2. Does it work? Yes, it's an even number, so it's gonna work. So we calculate the result. It can be 27 and 3. So now again, 2. Does it work? No. 3. Does it work? Yes, we get 91. Sorry. Uh, 3 works and we get 91. So we see that 3 does work. So 2 didn't work with 273, but 3 did. So we wrote the 3 over here, and the answer will be 91. And 91, we're not gonna try 2 anymore because 2 didn't work the last time. We'll continue with the next smallest one, which was 3. We try 3, didn't work. We try 5, didn't work. We try 7, does work. So this is 7. Result is 13. For 13, we start with 7 because already this stuff didn't work for the last number. So none of them works. 7 itself doesn't work. 11 doesn't work. 13 is a prime number. Okay, we hit 1, we stop. Because you remember, step 4, once you stop, once you hit 1. So you see, we hit 1. So then 546 will be written as 2, 3, 7, and 13, whatever that was in Italian. Okay, that's it. Now, find HCF and find LCM. See you next class for those ones. Bye-bye. Let me finish the recording. Where the hell is that? Yes, stop it. Bye-bye. Jeez, bye-bye.